Okay, kiddos, let's do some calorimetry practice here. I'm going to quickly go through these review notes and then we're going to try some practice problems. So remember what a calorimeter is, okay? It's simply a device we use to measure how much heat was lost by one item and that was gained by the other. It's a closed system. It's a closed system. That means that no heat escapes. Nothing escapes. All the heat remains inside the calorimeter. It's simply being transferred from one object to another. In our case, it's going to be transferred from the metal to the water because we're putting a hot piece of metal, we're submerging it inside cool water. Now what happens to the metal if it's hot and you put it in water? It cools down, right? It's going to cool down. The amount it cools will be the same amount that the water heats up. Okay, now they're going to even out and the final temperatures of both the water and the metal are going to end up being the same thing. Okay, remember, no heat leaves. All the energy remains inside this closed calorimeter, so we can easily measure how much heat was transferred. Okay, so the metal is losing heat. The metal is losing heat. So that's why we have that little negative sign there to indicate that it's losing heat. So this says that the heat lost by the metal is gained by the water. Okay, negative Q metal equals positive Q of water. The negative sign indicates that energy is lost. So here is our calorimetry equation. Mass times specific heat times change in temperature. So here's what specific heat is. The heat required to raise the temperature of 1 gram of a substance by 1 degree Celsius. Water has a very high specific heat. That's why it takes a long time to boil water. Okay, the specific heat of water is down here, 4.18 joules over grams degrees Celsius. That's going to be the specific heat of water. Okay, so here's our equation. Okay, MC change of T for mass times specific heat times change in temperature. I call it MCAT. That's what it looks like, MCAT. So we're going to use the MCAT equation. So let's try a practice problem here. So we have a piece of copper is heated to a temperature of 91 degrees Celsius and placed in 125 grams of water at 25 degrees Celsius. The final temperature of both the water and the metal is 31 degrees Celsius. So we see that the metal cooled off a lot and the temperature of the water raised a little bit. The specific heat of copper is 0.39 joules over grams degrees Celsius. What is the mass of the piece of copper? Okay. While we go on this, you might hear some background noise. Please disregard it. My son woke up and he is now watching YouTube, various cartoons. So we're going to start by making a little chart. We're going to make ourselves a little graph. Okay, so we have negative Q of the metal equals Q of the water. Okay, so over here we're going to make our little graph for our variables. Mass, specific heat, the final temperature, and the initial temperature. So let's fill in everything. So it says a piece of copper is heated to a temperature of 91 degrees Celsius. That's our initial temperature for the water. Placed in 125 grams of water, that'll be our mass for the water. At 25 degrees Celsius. 25 is initial temperature of the water. The final temperature of the water and the metal is 31 degrees. So final for both, 31 degrees. Specific heat of copper is 0.39. What is the mass of the copper? So we don't know this. That's our mass. The specific heat of water we know, 4.18. That is our constant. So that's the information we know. We have to figure out mass of the metal from all of that. So be sure you have that copied down. You should have this same exact handout. Okay, I'm working with you. I'm going to give you about 5 seconds. Pause the video at this time. Get this information copied down because I'm going to need to erase it to work out the problem for you. Okay, so let's work this out. I need to erase it to give myself room. Okay, so here we go. So remember, negative Q of the water. Let me make it a bit bigger. I'm going to have to write all the way across. I'm going to give myself plenty of room. Okay, so we have negative Q of the water. So we're going to have negative mass. That's what we're solving for. Specific heat of the copper times change of temperature of the metal. Our initial temperature was 91 degrees, final temperature 31 degrees. So we're going to have to subtract final minus initial. 31 minus 91 comes out to negative 60. This is why it's very, very important not to forget the negative sign at the very beginning, because these two negatives are going to cancel each other out. If you forget a negative sign, you're going to end up with a negative number. We can't have a negative specific heat. It doesn't exist. Not possible. So that is the metal information. Okay, so let's plug in everything for the water. 125 grams for the mass. 4.18 for the specific heat. And the temperature change for the water started out at 25 degrees. It heated up to 31. So that's a temperature difference of 6 degrees Celsius. Now, I want you to notice how the metal decreased by 60 degrees, but the water only increased by 6 degrees. Okay? That's because it takes a lot of heat to get water to heat up. Water has a very high specific heat. It takes a lot of heat to get it to go up even 1 degree. That's why there's such a huge difference. The metal cools down 60 degrees, but it's not a 1-to-1 ratio. The water isn't going to heat up 60 degrees. Okay? It only heat up 6 because of the specific heat of water. So, working out this math over here, we're going to multiply 0.39 and negative 60, and then the negative signs are going to cancel each other out, so we end up with 23.4 m. Okay, and then over here, multiplying these three numbers together, we're going to end up with 31.35. A little bit of algebra. How do we solve for m? Divide both sides. So the mass of our metal, 134 grams. Final answer. Okay, simple as that. Plug everything in, do a little bit of algebra to solve for the final answer. Okay, so there's one more that we're going to do. Challenge yourself. Pause the video now. Work out number 2 on your own. Work out number 2 on your own. Okay, and see if you get the correct answer that I do. I'm going to give you about 5 seconds, give you a chance to pause and work it out on your own before I start to work it out. Okie doke. So remember, we have okay, negative Q for the metal equals Q for the water. Let's make our little graph. So I have mass, specific heat, final temperature, and initial temperature. So 30 grams of a metal sample. I'm going to fill this in as I read the problem. So 30 grams of a metal sample at a temperature of 120 degrees Celsius are placed in 80 grams of water at a temperature of 15 degrees Celsius. The final temperature of the water and the metal is 21 degrees Celsius. What is the specific heat of the metal? So we don't know this. Specific heat of the water is always the same thing, 4.18 joules, grams, degrees Celsius. So we have our little chart made up. We just plug it in and solve for that missing variable. Okay, so let's start plugging everything in here. So negative, so I have negative. We know the mass of the metal. We're solving for a specific heat. And the final temperature. Not the final temperature, the temperature change. Temperature change. Final minus initial. 21 degrees minus 120, negative 99. So that's the information for the metal. Now we need to set that equal to the MCAT equation, plugging in the information for the water. So 80 grams was our mass. We know the specific heat of water, 4.18. And our temperature change, final temperature was 21 degrees Celsius, initial temperature was 15, so a temperature change of 6 degrees Celsius. So here's our MCAT equation with all the information for both sides. So now we just multiply everything out to solve for C. So on the metal side, multiplying everything, we come up with negative 2970 C. On the water side, multiplying everything out, I come out with 2006.4. These two negatives will cancel each other out, so it's simply 2970 C equals 2006.4. Little bit of algebra, right? We're going to solve for C. How do we do that? We divide by whatever's next to C. So I'm going to divide both sides by 2970. And the specific heat of water that we come up with, 0.68 joules per grams degrees Celsius. Final answer. Okay, so don't be afraid of these problems. These problems are a lot easier than they look. Okay, all you have to do, set up your little graph here, your little chart with all your information, and just set both MCAT equations equal to each other, solve for the missing variable. Okay, that's all there is to it. Don't be afraid. There ain't nothing to it. Easy cheesy, lemon squeezy. So we're going to shoot for a quiz over calorimetry. Today's Thursday, so I will go ahead and post a quiz on Monday. I want to give you all today and tomorrow. Have plenty of time to practice so you're well prepared. And we'll quiz over this stuff on Monday. If you need help, reach out to me. We can Zoom. I can tutor you, answer whatever questions you have. Alrighty, kiddos, that is it. Happy Thursday.